Greetings everyone and welcome back to the bench. Today's little project is to build a tube amplifier on the breadboard using one of these audio output tubes. They are quite high hour tubes. I'm hoping they still have life left in them. You can see here the darkening. The getter flash looks good on these though, so they're not gassy or anything. But hopefully these are good enough I can still use them. Now here's the thing, they don't have any part number on them. There's some numbers up here, but that's not the actual part number. It just says made. Problem with some of these tubes, the ink they used rubs off easily, so I have no idea what these tubes are. I'm not a repair technician, and I'm not super familiar with tubes. I've tinkered around with them before, so maybe somebody can tell me what type of tube these are, what part number. I think they're an ECC tube. They came out of a Telefunken receiver. Now these are not your ordinary output type tube. They actually have two stages. They have a preamp stage, a little triode stage right here. You can see it's its own separate unit here inside the tube. This larger part is probably a pentode, a power pentode for actually driving the output transformer that's connected to the speaker. Back in the early 50s, maybe earlier than that, I'm not sure, they came out with miniature tubes, and the idea was to be able to put more parts inside one tube to cut down on the size and the cost. So you can think of it as an integrated circuit for the tube days. They had tubes that would have 3 triodes in them, dual diode and a single triode, but this has a triode and probably a pentode in there. So that's kind of nice. I can actually make an amplifier just using one tube, and it'll have 2 stages to it. The thing is, not knowing the part number, I'm going to have to guess at some of the tube parameters. They're probably fairly typical. Something like a 12AX7 might be a similar triode. Small pentode. It's not really the power of an EL84 or a 6BQ5. It looks a little smaller than that. So using similar parameters, I think I can set up an amplifier and tweak it to get it right. So what I had to do is get the pin designations here. As you can see, I looked at the tube through a magnifier and figured out what was hooked up to what. So I got the pin designation here. I think everything's right, and everything marked with triode in front means it's for this little triode section, so I can differentiate what plate goes to the triode and what grid and so on and so forth. Next is to set up a supply. Now this supply is not ideal. I just had to use parts that I had. I only had 200 volt 33 microfarad capacitors that I took out of old CFLs or old LEDs that I tore down. So it's not ideal. I just got parts enough that I think it'll work. So here's the supply. So I have this transformer. So I have a 220 volt windings here. I'm using this side for the isolated side, and I'm adding another 30 volts from another winding over here. So after full wave rectification, I should be close to 180, 190 volts. And again, I probably should go higher in voltage, but these capacitors only are 200 volts. That's as high as I have on hand. So that's what I'm going to do here with this power supply. So we have the supply for the output section of the tube, and it runs through another filter here and to the triode preamp section of the tube. What I did here is I put an LED and another resistor that drains off the charge. So if I turn this thing on, you can see the LED came on, and when I turn it off, it's going to take a while for it to discharge. I could put a lower value resistor here, but it will discharge and make it safe. Of course, when the tube's hooked up, the bias will drain off the charge a lot faster. Next, after that, I come up with a circuit. Again, this is just using very basic values, and in fact I don't have all the values labeled at this time. So yeah, I'm just using a 1K in the cathode of the preamp section, this triode, 100K here. And sometimes in these simple amplifiers they'll bring the plate over to this plate, and it's actually forming a feedback loop, and I don't know what value to use just yet. That's something I'll put in later, and we'll just see how the gain is and what I can afford to put in there. And I have an output transformer. I don't know where it is at this time. I have to dig it out. I know I have one around somewhere. I have to figure out the screen resistor here to use. I'm not totally familiar with what values you're supposed to use, but I've seen all kinds of different values used here, and I'm not sure what the grid voltage should be relative to cathode, so it's going to be cathode biased. I'm going to guess there's probably 30 or 40 milliamps flowing through this tube, so if it has 8 volts, I can do the math and the Ohm's law and figure out what this should be. And of course I'll have to fine tune it depending on how worn this tube is and what its actual value should be. But yeah, that's just a part of tuning it up. But yeah, it's a pretty basic, simple circuit. See if I can get something going here. Okay, I have this thing almost all the way set up. I found a socket. I had to solder some more wires on it because some of the pins were not used. Of course, with this tube they're all used. You can see the filaments are glowing there. Power supply is on, so I'll have to be careful because there's high voltage there. So I'm using my music player over here to inject a signal. It's going through the preamp. So let's see what's going on here with the scope. The plate supply to the preamp is 160 volts, and I'm getting 80 volts on the plate of the triode portion of the tube. And this is the signal I'm getting. So it's clipping on the top. So it's not very balanced. I'm going to have to see if I can fix that and get it to clip symmetrically. The idea is to get the amplifier working in parts. I don't care about the output stage yet. I want to get this working before I hook it up. Why hook it all up and then be chasing your tail figuring out what's going on? I already see there's a problem here. So I'll tackle that, get this going, and then hook the output stage up and get that running correctly. Of course, when I send some feedback, it's probably going to throw it off, so we'll have to deal with that at that point. But for now, I'm going to see if I can correct that problem with the preamp stage. Okay, I'll just point the camera at the scope here. Now I'm scoping off the plate of the triode. To make this easy, I just put a potentiometer, a trimmer here, as the cathode resistor. So as I turn the resistor value lower, it increases the gain. And of course we don't want it all the way down. We don't need a lot of gain, but see, as I turn this down, I can't get rid of that flat top. It's just not going away. Maybe I'm putting too much signal into it. Let's turn this way down. See, it's still there. Let's turn this up. And this isn't good, is it? Maybe this tube is just shot. This is just not pretty. It's just too distorted. It's flat topping. Yeah, it's kind of soft clipping it now. I'm at such a low level, but yeah, it's not looking good here. Well, let me plug that other tube in and see what it does. Okay, I have this figured out. It was just me being stupid. What I was doing here, if I can find my diagram, I have this capacitor in the circuit, and it's connected to this tube. The plate's not connected to anything on the output section. So it was shorting the signal through this tube, probably leaking through the cathode, which is connected. You know, the plates, I don't think the grid's connected. I don't think, well, the plate's not connected. I don't have the output transformer. It was just shorting the signal. You know, duh. Look at that. Beautiful waveform now. Beautiful waveform. So if I adjust the cathode resistance, of course, as I turn it down to nothing, the gain goes up higher. We get a very big signal. And let's see what. Of course, it's very distorted as well because there's no feedback. But you can crank this thing up high until it starts to actually clip. Yeah, we're at 20 volts per division. We're getting a lot of amplification. I don't want that much, plus the distortion. So turn that down quite a bit. Let's see, where should I go? About here. Let's see, that's all the way down, somewhere in the middle here. And that's 10 volts per division. Of course, I have the preamp turned all the way up. I don't need that all the way up. This preamp would drive the output section on its own, but that's not what I'm after. I want to use that preamp tube. So yeah, this tube is good. I can turn the filament voltage up and down, and it doesn't really affect the bias that much. So these tubes seem to be good, at least the triode section of it. Okay, so good. So now I can continue on and figure out what to do with the output stage. Okay, this is just signal leaking through. Let me fire the plate voltage up here. There it is. Turn that guy down. I went with a 4.7K cathode resistor on the preamp triode section. That seems to be not very nice looking waveform. So now I'll build out the output section of the tube and see how that works out. Okay, I found this little bitty output transformer. I really could use a bigger one. Maybe I'll see if I can find one. I don't think I have one though. And I got the output stage all hooked up. So let's take a look here on the scope and see what we get. I should say, headphone users beware. gonna get loud. I can hear it's a 1 kilohertz signal with it's laden with harmonics. It does have my 4.5 kilohertz pilot signal in there though. Let's take a look at the distortion. First of all, I'm gonna hook it up to a resistor here so I can properly get distortion measurements instead of blowing my ears out with the signal. Stay tuned. Okay, we're looking at the distortion now. First of all, see where there's clipping, and it's starting to clip on both. Starts to clip here a little bit first. So I'll turn that down to about there. And let's put some waveforms on the screen. Turn that off. This is the 1 kilohertz pilot signal. First of all, if you're new, this is the FFT 1 kilohertz fundamental 4.5 kilohertz pilot signal. You see it's pretty much right at 1% of the fundamental. So we have a second order harmonic that's 1, 2, 3, 4, 5%, and a third order that's 2, and a little nub of 1 that I don't care about, fourth harmonic. That's pretty much par for the course for tube amp, but there's not really doing anything with negative feedback. I want to see if I can add some negative feedback and clean up the signal just a little bit. Here's with the feedback resistor installed. It's going from the plate of the output stage to the preamp stage, and yeah, it really cut down on the distortion. I tried a 220K and it killed my gain too much. And the distortion would probably be a lot better, but it just kills the gain too much. And yeah, this isn't bad for a single-ended tube amp. Yeah, now we're 2.5% total harmonic distortion on the second harmonic. You know, that's not bad. I'm measuring the output on the speaker side of the transformer, output transformer. It's just a little rinky-dink transformer right there. Well, here's the finished circuit. Like I said, it's only on the breadboard. Of course, the power supply as well. And I'll give you a little sample of the sound. I don't know if you can hear that. There is some hum coming through. I could use larger capacitors, even a inductor on the power supply, clean it up. But let me play some music here.
Some will still you, and some will still be working hard to become what I am. Flow down the river like drifting wood. I'd swim to the shore if I only could. Call out your name and take your hand. Find the words that you understand. I went down to the cellar till I'd know the door.
I can kind of pick up a little distortion on the bass notes. I am running it near clipping. Only getting 2 volts RMS output into 8 ohm load, so you know, it's half a watt. Again, I think I am starved on the supply voltage here because I can only go so high with these capacitors that I have. Really need to operate this thing more like 250 volts. And it is kind of a smaller tube. You have the preamp stage taking up part of the volume inside. So it's not going to be a high power tube anyway. It's probably no better than a watt or two. Of course, I don't have a very good transformer, like I said. So let me give you the schematic before I wrap this up. Here is the finished schematic. Quickly, the power supply. And that's the plate on the output. That's the preamp plate. And here is the schematic. I did add a blocking capacitor and this resistor to ground. So as I adjust this resistor, I can monitor the voltage here. I did have this at 4.7K, I think I said earlier, but the gain was too low, so I brought it back down to 1K. I think I said that, yeah, I think I went through this before, how I chose this resistor. 220 ohm, that gave me 7.1 or 2 volts difference here. In other words, a negative 7.1 volts on the grid here. On the grid, I just used a 10K resistor. That's one thing I didn't play around with, but I don't think it would have made any difference. The feedback resistor ended up being 470K, as I mentioned before. I had 4 ohms here before, but I actually used 8 ohms during the test. I'm not sure what this transformer is capable of. It might be a 4 ohm transformer. But yeah, I got half a watt. That's pretty much expected. I think maybe if this is 4 ohm, I could get a little bit more power. Again, running this at around 180 volts, I'm not going to get the full potential, so it might do a watt and a half. Like I said, I don't think the tube's capable of much more. Yeah, I don't know what tube this is. I'm kind of flying by the seat of my pants here. Bypass cap just to increase the gain. So that's about it, really. Not much to it. Just something to play with on the bench. I was kind of curious if these tubes were good. They seem to be good. And here is the Snickers. He packed it in for the night. He's going to bed. This is his night sleeping position. He sleeps different places, different times of the day. And when he moves over here, it's pretty much for the night. And what time is it anyway? It's 9 o'clock. So yeah, it's a little early there, Snickers. So that'll do it for this one. Thanks for watching.